Okay, so we're going to call this 5.4 solving. We're going to call it B, harder problems. Okay, so don't be alarmed. We're going to practice these, and it's nothing you haven't done before. Okay, so nothing you haven't done before. So here we go. I also want to, well, let's see. I'm going to show you these type of problems first, so that you're not alarmed and that you see that it's really not different than what we've been doing. Okay. And that is my trusty cat that was trying to photobomb my video. Okay. That was my other fur child. Okay, so notice just because it's a radical here, or not a radical, an exponent doesn't mean that you have to treat it any differently. So I'm still going to onion this. Okay. So when I onion this, I want to get the x by itself. I still want to isolate. So one of the first things I'm going to do is I'm going to divide by 2. Because this x to the 2/3 power needs to be isolated. Okay, now I need you to think about this for a second. Okay, so I need to do a little side note. Okay, like a little side note. All right. What does x to the 2/3 really mean? Well, that is the cube root of x squared, right? Okay. Now remember from the problems before, when we were solving, if it was just the cube root of x, instead of cube rooting it, we would take it to the 3rd power, correct? Okay. So that's not. So literally, we'd still be doing the same thing. So instead of taking the cube root, we're taking it to the 3rd power. Now, what's the opposite of squaring the x? Square rooting it. So what we're going to do is we're going to raise each side to the reciprocal power. Now look at that for a second and think about it. Okay? Think about this for a second. Okay. Another side note. What do you get when you do 2/3 times 3/2? 6/6, right? Or just a 1. So this cancels out and I just get x. And here we've already done problems like this. Now, can you put this in? So this would be appropriate to actually solve and get a decimal answer for this. If I ask for a decimal answer, but remember that this 4 to the 3/2 means the square root of 4 cubed, which actually is 8. And you can do that on your calculator. I'm not going to make you do it without a calculator. So part of this new piece is looking at exponents. Again, this is why we studied this. Exponents and the radicals are no different. Okay, they're just written a little bit differently. All right, well, how about this one? X to the 1/4 plus 3 equals 0. All right, so I want to get this all by itself. All right, so what's the first thing that I need to do? You're right, -3 on each side. All right, now before you say, oh, I can't do the 4th root of 3, and you're right. Remember that this is the 4th root of x. In fact, if you'd rather go back and write it like that, friends, for your next step, I would be so happy that you would do that. That's fine, but you don't have to. Okay? But either way, looking at this makes it easy to see that I need to raise it to the 4th power on each side. Up here, if I were to write it, I'm going to write it to the 4th power, or 4 over 1, just so that you can see that 1/4 times 4 over 1 gives you nothing, or gives you a 1, okay? So what is -3 to the 4th power? Well, let's see, -3 times -3 is 9, so that would be 81. Okay, so this is kind of interesting. So if you stop for a second, okay, and the reason I'm bringing this up is that this is kind of an interesting problem, okay? If I take and I check my work here, what is the 4th root of 81? It's a 3, right? And will 3 plus 3 ever give you a 0? Now, be careful, okay? Be careful, because when we think about taking the 4th root of 81, you would normally have given me a plus and minus 3, right? But because there is no property, you know how the properties, like if I add a -3 to both sides, that's the subtraction property of equality. If I add each side, there is no property to raise something to a power or take the radical of each side. That's not a property. Therefore, we'll sometimes get a solution. Technically, it's really not a solution. Okay? All right. Let's do this one. All right, we're going to give this one a try. This one's going to challenge us a little bit. All right. Okay, I have an X over here, and I have this, but this is, I need to get the X's together. So I need to get rid of this 1/4. So the opposite of taking something to the 1/4 would be taking it to the 4 over 1 power. And what I do to one side, I have to do to the other, okay? So I'm left with 5x squared minus 4 equals x to the 4th power. Now, don't groan. Here's what's going to happen, okay? If I have x to the 4th, I'm going to move everybody over to this side, and I'm going to factor, okay? So I'm going to minus 5x squared, and I'm going to add 4, and I'm going to tell myself I am a factoring master, and I can do this. And just because it's a 4 doesn't mean that I can't break this up into a squared and a squared. And my signs are minus, minus. And factors of 4 that add up to give you 5 would be 4 and 1. And friends, I know that you can recognize that these are both the difference of 2 squares. In fact, if I were to solve it out, remember that this could get factored into x minus 2x plus 2. This gets factored into x minus 1, x plus 1. So I would ask you, what's your answers? Well, it's not really a -2, it's positive. It's not really positive, it's negative. It's not really negative, it's positive. It's not really positive, it's negative. This actually has 4 roots. If you were to graph this, set it equal to 0 or y, it would actually touch the axis that many times. Now, this is a good segue into the second part of what we're doing as far as the problem. So here we go. So now let's continue our square roots here. So I'm going to do some simple one just to start out. Okay. All right. I need to isolate the radical. I did that. Okay. Now what's the opposite of square rooting? Squaring each side. Right? Okay. This squared is not x squared and 36. Okay, friends, we're gonna continue so we're gonna square each side, and this piece is where we can really goof this up. So this piece right here, squaring this is like saying x minus 6 times x minus 6, okay? So here we go. So this becomes x times x is x squared. X times this is 6x. This is negative 6x. And 6 times a negative 6 is a positive 36 equals 3x. It is not squared on this side because on this side, just the square and the square root cancel out, okay? All right, let's collect like terms. Let's see, x squared negative 12x plus 36 equals 3x. Now I've got an x squared. You know what comes next, right, friends? Yeah, we're going to have to factor this. But in order to factor it, I need to get this and pull it over here. Okay, so factors of 36. So let's get our factoring pathway sheet out. We're thinking about this. This would be a minus. Factors of 36 that add up to give you 15. Let's see, 9 and 4. How about 12 and 3? Yep, 12 and 3. Doesn't matter where they go because they're both minus. So this really isn't a negative 12. It's really a positive 12 and a positive 3. Do a quick check. Do either of those make the inside of this negative? No. Now we're good. Neither one of those make that negative. We'll be good. Oop, except for this. Look at this for a second. Hang on. So look at this. So x minus 6 equals the square root of 3x, right? If we plug in 12 here, I get 6, and the square root of 36 is 6. That one's good. But look what happens here. What's 3 minus 6? Well, that's a negative 3. And the square root of 3 times 3, the square root of 9, is 3. Now, you could argue, well, Mrs. Bassett, that could be a plus minus 3. True. But remember that doesn't jive. There is no property of the squaring property. So technically, we would say that the 3 doesn't work, but the 12 does. Okay. Maybe I'll include a quick video too of how that property doesn't work. Okay. Let's do one more like that. I'm going to do one like this. I think you can handle this. The fourth root of 3 minus 8x squared equals 2x. Okay? All right, so what is the opposite of taking the fourth root? Taking things to the fourth power. Sorry that this auto adjusts, okay? If that makes that kind of confusing. So 3 minus 8x squared equals, okay, what's 2 to the fourth power? 16, and an x to the fourth. Okay, so x to the fourth. Looks like I need to move everybody to this side. Okay, and very similar to what you did up in this one, 0 equals 16x to the fourth plus 8x squared minus 3. So plus 8x on each side plus 8x squared minus 3 minus 3. Okay. All right. So can't divide. Looks like I might need to do the Cole-Brooklyn method. So 0 equals x to the fourth plus 8x squared minus 48. I'm running out of space, but that's all right. How do I break up x to the fourth? X squared. Okay, x squared. One's a plus, one's a minus. Factors of 48 that subtract to give you 8. Let's see. 8 and 6 doesn't work. How about 12 and 4? Yep. So the 12 needs to go with the plus, and the 4 needs to go with the minus. And don't forget to divide by 16. Okay, so the question here is, this was a little bit different than what we did previous. We were actually able to break this down farther. You could do the difference of two squares. Let me show you a different way to do this. So let's set this equal to 0, okay? And you know what? I'm going to flip my paper over real quick. So what was that? X squared equals 12 over 16, right? And x squared minus 4 over 16, right? Okay, so in this case, we want answers. So let's take each of these and set them equal to 0. Okay, so I would minus 12/16, which seems really yucky. But right here, when I take the square root, can I do that? No. That's imaginary. I can't take the square root of that negative number. Okay? Or you could say, yeah, I can do that. It's I, and then the square root of 12 over 16, you could come up with the decimal answer for that. Your other piece, okay, this would be plus 4 over 16. I should just reduce that, right? What's 4 over 16, friends? Yeah, that's 1/4, right? Square root each side. Oh, that I can do. And the square root of 1/4, friends, is plus and minus 1/2. Now, if we go back to the original problem of the fourth root, 3 minus 8x squared equals 2x. Okay, we already know that the imaginary answer doesn't work. How about the 1/2 though? Okay, so is this going to work for a negative out here? It's not, is it? So my answer cannot be negative because the fourth root is not going to be a negative answer. So my only answer is 1/4. Okay. So it really is very similar to what we've been doing, but putting it all together. Now, wonder if you can't factor. What's our other option? The quadratic formula. So yes, friends, you're going to have to do that. All right, see ya. Thanks.